Professor Baldwin here, and today we're going to learn about the hyperbola. So up top you have a little description of what a hyperbola is and a picture of a standard hyperbola. We're going to concentrate on some different types of hyperbolas. The first two we're going to see are hyperbolas that have a center at the point 0, 0, or their center is at the origin. You can have a transverse axis horizontal or a transverse axis vertical. The transverse axis horizontal means that the horizontal axis cuts through those two graphs of the hyperbola. And the vertical, you'll see that a vertical line would cross through those two graphs. The other notable difference, or a way that you can easily pick out which one you have if you don't have a graph, is which variable comes first. In a transverse horizontal, you have your x squared first, and then it's subtracting the y squared. In a transverse vertical, it's the y squared first minus the x squared. Now, if you're given some points, the vertices or the foci, then it depends on where you have the value. So for a transverse axis horizontal, notice that all of these points have a 0 in the y spot. But the x-coordinate is the number. So if you have a value in the x-coordinate position, then it's a horizontal. And if you have the value in the y-coordinate position, it'll be a vertical. And remember, this is if your center is at the origin. Now, what if we have a center that is at some other point, hk? Well, h changes your x variable. It doesn't matter if your x variable is first or second. H always goes with the x, and k will always go with the y variable. Now, transverse axis horizontal and vertical, when there's a center at a point hk, these are going to have asymptotes. And here are your equations to find the asymptotes for the different types. Notice that these asymptotes are slant asymptotes. And the other key point, they will go through the center. See how both asymptotes and both graphs go through that center point, hk? That is key to help you quickly graph the asymptotes and then to quickly graph your hyperbola. Don't worry, we've got an example. Okay, our first example. We're given some information or conditions about a hyperbola, and we're asked to find the equation. So we need to use all of the hints that we're given. So, first hint. Notice that we have zeros in the x-coordinate position for all of our given points. That means two things. One, our center is at 0, 0. And then we know that it's transverse vertical, right? Because vertical is y, and we have values in the y. And knowing that tells us the equation we need to use is y squared over a squared minus x squared over b squared equals 1. Okay, now we need to figure out what a and b are. So we need to remember that the vertices tell us the value of a, and the foci tell us the value of c. And remember the relationship, c squared equals a squared plus b squared. So we know c is 5, so 5 squared equals, we know a is 3. So now we can solve for b. We have 25 equals 9 plus b squared. My pen doesn't want to work. Subtract 9 from both sides and we get 16 equals b squared, or b is going to be equal to 4. So we can write the equation y squared over a squared minus x squared over b squared equals 1. Not too bad, right? Okay, let's move on to our last example. And it's going to take the whole page because this is a pretty complex problem, but it's one that you have to be comfortable with. So, here we go. We need to find the center, the vertices, the foci, and the asymptotes, and then we have to draw the graph by hand. But notice, this isn't in that standard form, so we need to put it into standard form. First step is to get all of our variables together. So we want our y's together and our x's together. So we'll have 9y squared minus 18y minus 4x squared plus 24x. And we're going to move the 63 to the other side, right? Add it to both sides and we get 63. Okay, let's factor out so that we can get ready to complete the square. So for y, we have 9 times y squared minus 2y. Okay, the leading coefficient is now 1, so we can complete the square of that. Let's pull out a negative 4, and we have x squared minus 6x. Leading coefficient for our x squared is now 1, so we can complete the square on that. And it equals 63. So now we need to complete the square twice, just like we did with circles. And first we'll complete the square with the y. To complete the square with the y, you take your b, which is negative 2, divide it by 2, and then square it. So that's negative 1 squared, or 1. Let's complete the square with our x, and then we'll move on to the next step. That would be our b, negative 6, divided by 2, and then squared, or negative 3 squared, which is 9. Okay, completing the square. Now we can add it back in. So for the y, we have y squared minus 2y, and we add that value from completing the square. Now we're going to do the same thing with our x. X squared minus 6x plus 9. But now we have to deal with the right-hand side. And this is where you have to go slowly. You don't want to make this really common mistake. Okay, for our y, to complete the square, we added a 1, correct? But that 1 is being multiplied by a 9 because we had to pull out that GCF. So we need to add 1 times 9, or 9, to the right-hand side. Now look at our x. When we completed the square, we had to add 9, but that's being multiplied by a negative 4. 9 times negative 4 is negative 36, so we have to add or subtract a negative 36. So we're adding a negative 36 or subtracting a 36. Okay, don't miss that step. If you had to pull out a GCF, you need to use that GCF to increase the amount that you're adding or subtracting on the right-hand side. Otherwise, it doesn't stay balanced. Okay, let's finish completing the square. We keep that GCF on the outside. And remember, completing the square is giving us a binomial squared. And that second term always comes from the value we had right before we squared when we're completing the square. So here it's negative 1. And then for our x, it was negative 3. And we can simplify the right-hand side. We should get 36. Okay, remember that hyperbolas need to be equal to 1. So we need to divide everything by 36. This step is another place that you're going to catch if you maybe messed up not doing the step above of the GCF times you're completing the square. Because if you get to this step and you don't have something that easily simplifies, you know there was a mistake a little bit earlier on. So go back and double check your work. Here, 9 and 36 and 4 and 36 have values in common. They're going to simplify each other, so we know we didn't make a mistake. So 9 and 36 simplify. We're left with y minus 1 squared in the numerator and a 4 in the denominator. Minus the 4 and the 36 simplify to a 9 in the denominator, and we're left with x minus 3 squared in the numerator, and this is equal to 1. One more step and we'll be at that true standard form. So we really want our denominators to be something squared, and 4 is 2 squared, and our 9 is 3 squared equal to 1. Okay, this is where I like to use this extra space on the right hand side and start writing out the things that I know. The things that I know I need to find, and the things that I know I need to find in order to find the things I need to find. Tracking? Good. Okay. We need to know the center. And the center is found with HK. We also need to find the vertex, or the vertices. And those are found for this specific type with H and K plus or minus A. We also need to find the foci, which are found with H and K plus or minus C. So notice we need some things. We need to know H, K, A, and C. Well, what do we know? We know H. H is the value of our center that corresponds with the x coordinate. So it's the value with your x variable, and it's what you're subtracting, which is 3. K is the y coordinate for your center, so it's associated with your y variable. Here that's 1. A is the denominator of your y variable, and it's the value that's being squared, so it's 2. B is the value from your x, and that's 3. Now what about C? C we need to find. Recall that c squared equals a squared plus b squared. So c squared for us is going to be equal to 4 plus 9, or 13. Which tells us c squared equals 13. In order to get c, you take the square root, so c is going to be the square root of 13. Okay, so we know our center. Our center is the point HK, so that's the point 3, 1. We know the values for H, K, and A, so we can find our vertices. The first coordinate, the x coordinate, is 3 for both of them. My pen will cooperate. Next, we have 1 plus or minus 2. So 1 plus 2 gives us a 3. 1 minus 2 gives us a negative 1. So we have the two values for our vertices. Now, our foci are going to start with the value of 3 for the x coordinate, and then it's k plus or minus c. K is 1 plus c, which is the square root of 13, and the other one is 1 minus the square root of 13. Awesome. Now we have one last thing to find, and then we can actually graph. And what do we have to find? We have to find our asymptotes. And remember, your asymptotes are going to be linear equations. They're going to end up being slant asymptotes here. So it's y minus k equals a over b times x minus h. And the other one is y minus k equals a over b negative times x minus h, right? One needs to be positive and one needs to be negative so that they'll make that cross pattern. Now we can substitute in everything that we listed as known above. So y minus 1 equals 2 over 3 times x minus 3. Let's solve this first one for y. So first I want to distribute that 2/3. So 2/3 x, 2/3 times a negative 3 will give me a negative 2. I need to add 1 to both sides, and my final linear equation is y equals 2/3 x minus 1. Okay, the second one, I have y minus 1 equals negative 2/3 times x minus 3. Let's distribute that negative 2/3. So negative 2/3 x plus 2 here. We're going to add 1 to both sides, and the final equation is y equals negative 2/3 x plus 3. Now, we needed to give the asymptotes, but when we graph them, we're only going to need to use that slope, the 2/3 and the negative 2/3. And I'll show you why in a second. So let's scroll back up to our graph and plot our center and our vertices. Our center, I'm going to plot this in bright green. So our center is the point 3,1, which is right here. Now our vertices, we have the point 3,3 and the point 3, negative 1. Okay, now in order to be able to draw the hyperbola, both of those curves, we really need those asymptotes. And remember I told you to draw the asymptotes, we only need the slope. That's because the asymptotes go through the center. So if you start at the center, you can use each of your slopes to get the lines. So our first slope is positive 2/3. So we would count up 2 and to the right 3, and that gives us a point. Or you can do the opposite, down 2 and left 3. So here is our first asymptote. Now our second one is a slope of negative 2/3. So from the center, you would go down 2 and right 3. Or you can go up 2 and left 3. See how it's giving us that negative slope? Let's give ourselves this dotted line. Remember, the asymptote is the line that you're not going to cross. Now we have enough information in order to complete this graph. Or if we needed to pick it out from a lineup, we know what it's going to look like. So we know that this upper part is going to approach these two asymptotes but never touch, and likewise with the bottom. There you have the graph of this crazy hyperbola. That was a lot of work. I hope you were able to follow along. If you still have a question or you come across one of these problems that you're stuck on and you need help, please reach out.